AWS most powerful services for managing resources across multiple accounts and regions. AWS Resource Manager, often abbreviated as RAM, is game changer for organizations. This game changer for organization operating in multiple account environments. Think of it as a central nervous system that allows different AWS accounts to share resources seamlessly and securely. Throughout this presentation, we'll cover everything from basic concepts to advanced hybrid connectivity scenarios. You'll learn how to implement cross-account resource sharing, set up hybrid account connectivity with Direct Connect, and manage complex networking. Let me paint a picture of what AWS Resource Manager really is. Imagine you're running a large organization with multiple AWS accounts, maybe one for development, one for production, and another one for shared services. Traditionally, each account would need its own set of resources, leading to duplication and increased costs. AWS Resource Manager solves this problem by enabling secure sharing of resources across accounts. You can share VPC subnets, transit gateways, Route 53 resolver, and many other resources without compromising security or control. The key benefit includes significant cost reduction through resource consolidation, simplified management through centralization, and improved security through consistent policies. You maintain ownership and control while extending access to trusted accounts. Now let's break down the core components that make Resource Manager so powerful. Think of these as the building blocks of your multi-account architecture. Resource shares are like containers that hold the resource you want to share. You define which resource you want to share and principles under which condition. You define principles are the accounts really, AWS accounts, organizational unit, or AWS organization. Even you can connect across entire organization. The sharing process itself is elegant. You create a share, specify the resources and principles, and AWS handles the secure access mechanisms. Recipients receive invitation and must explicitly accept them, ensuring no unauthorized access occurs. What's practically more powerful is that shared resources appear in the recipient account as if it was something native to that resource, native to their VPC, but the owner retains full management control. AWS Resource Manager supports an impressive array of shareable resources, and this list continues to grow. VPC subnets are probably the most popular resource. Imagine having a shared services VPC with NAT gateways and internet connectivity that multiple accounts can use. This eliminates the need for each account to have its own internet gateway and NAT gateway. Transit gateways are also available, enable hub and spoke network architecture. One account owns the central transit gateway and other accounts attach their VPCs to it, creating a scalable network topology. Route 53 resolver rules are also fantastic for hybrid DNS scenarios. You can centrally manage DNS forwarding rules for on-premises domains and share them across all accounts. The networking components like security groups and network ACLs help maintain consistent security policies across your multi-account environment. This diagram shows a real-world multi-account networking architecture that I've implemented for several enterprise clients. Let me walk you through the design principle. Account A serves as the shared services hub. This is where we place our transit gateway, shared subnets, networking components like NAT gateway. This account is typically managed by the central IT system. Account B and C represent different businesses, units, or environments. Notice how they have their own VPC for workload isolation, but they can leverage the shared networking components that's offered in infrastructure from account A. The transit gateway acts like the central hub for routing, enabling any-to-any connectivity between VPCs and on-premise uh, services as well. Um, the transit gateway um, allows you to achieve connectivity across multiple environment with simplicity because the transit gateway is created on a shared services account and you don't have to create a transit gateway for each account or so that becomes an infrastructure considerable saving here. So centralized connectivity, single point for internet and hybrid access if you want, cost optimization, you can share the net gateway and security appliances, uniform security policies across accounts because you set up the security policy in the central VPC, shared in the central VPC, and this would be implemented across to the other organizations. Hybrid connectivity is where AWS Resource Manager really shines in enterprise environment. This sequence diagram shows the step-by-step process of establishing hybrid connectivity that can be shared across multiple accounts. The process starts with establishing a physical direct connection to AWS. Once that's in place, we create a virtual interface that connects to a direct connect gateway. And then the magic happens when we attach this gateway to our shared transit gateway. Through Resource Manager, we can share the transit gateway with other accounts, effectively giving them access to the hybrid connectivity without each account needing its own direct connect setup. This can save hundreds of thousands of dollars in enterprise environment. The shared routing tables and security groups ensure that hybrid connectivity policies are consistent across all accounts. AWS Resource Manager that doesn't exist in isolation. It integrates nicely with the broader AWS ecosystem. This diagram illustrates the comprehensive integration points that make it so powerful. At the computer layer, you have the EC2 instances and ECS instances and clusters can all leverage shared networking resources in the central VPC. This means your applications can run in their dedicated networking, dedicated accounts while using centralized networking constructs like the Transit Gateway or CloudTrail or AWS Config or System Manager. And then also your security groups are centrally managed as well. And you can implement AWS WAF and AWS Shield for additional services. The network and integration is extensive. Shared VPCs, transit gateways, load balancer, and Route 53 resolvers. Those rules create a unified network and fabric across your organization. Security services integration ensure that shared resources maintain consistent security and that shared security groups and network ACLs combined with AWS WAF and Shield provide defense in depth. The management services integration also as well is very powerful. You can maintain consistent security posture, shared security groups and network ACLs combined with AWS WAF and Shield provide defense in depth. The management services integration provides comprehensive visibility and governance. CloudWatch metrics, CloudTrail logs, and AWS config rules help you monitor and manage the shared resources effectively. So you can gain the visibility on CloudTrail and CloudWatch centrally, giving you the ability of getting broader visibility into the organization, different accounts. Implementing AWS Resource Manager requires careful planning and a structured approach. We always start with AWS organization. This is the foundation that enables trusted sharing within your organization. Without organizations, you'd need to manage external sharing, which adds complexity. The VPC and network and infrastructure comes next. I recommend starting with a simple shared VPC that contains your NAT gateway and internet connectivity. This provides immediate value and helps teams understand the concept. Transit gateway configuration is where things get interesting. This becomes your central routing hub, so plan your IP addressing carefully and don't have any IP addresses overlap. Resources sharing should be done incrementally. Start with less critical resources to build confidence and understanding, then move to more critical shared services. Cross-account access configuration require careful IAM planning. Use least privilege principles and document your access pattern clearly. The first step is to create an organization. This command creates the foundation for secure resource sharing. This feature set all parameter is crucial. It enables advanced features like service control policies, which you'll want for governance. If you only specify consolidated billing, you'll miss out on these advanced features. Notice in the output that AWS assigned organization ID. You'll see this in various resource sharing configurations. The available policy type show that service control policies are enabled, which is essential for production environment. This organization becomes the trusted boundary for shared resources. Any account you invite to this organization can participate in resource sharing without the complexity of external sharing mechanisms. Creating the VPC infrastructure is where your architecture really starts to take shape. This VPC will serve as the hub for shared networking services. Always start with a /16 IP. This way you don't have to worry about unless there is any overlaps that you want to avoid, but generally /16 is fine. It provides plenty of IP addresses and it's easy to remember. The tags are crucial for cost reporting and cost analysis. Notice how the VPC starts in pending state. AWS is provisioning the underlying infrastructure. The VPC ID in this output is what you'll use in all subsequent networking commands. This VPC will house your shared subnets, NAT gateways, and potentially security appliances like firewalls. Plan your subnet structure carefully. You'll typically want public subnets for NAT gateways and private subnets for shared services. Creating shared subnets is where resource sharing concept becomes tangible. This subnet will be shared across multiple accounts, providing centralized network services. The availability zone specification is important for high availability designs. In production, you'd really want to create multiple subnets across different availability zones for redundancy. The subnet CIDR must be a subset of the CIDR. Here is 10.01/24, which provides 254 usable IP addresses. This subnet will typically host a NAT gateway, proxy servers, or other shared network services. The type private is tag indicates that this is the private subnet. When other accounts use this shared subnet, their resources will inherit the subnet's routing and security properties. The transit gateway is the heart of your multi-account networking architecture. Let me explain each configuration option and why it matters. Default route association enabled means that new attachments automatically join the default route table. This simplifies initial setup, but you might want to disable this in complex environment where you need custom routing. DNS support enable is crucial for cross VPC name resolution. Without this, your applications can't resolve DNS names across VPCs. VPN ECMP support enabled allow equal cost multipath routing for VPN connection, providing better bandwidth utilization and redundancy. The Amazon side ASN 64512 is a default, but you can specify your own if you have specific BGP requirements. This transit gateway will become the central hub that all VPCs and on-premises networking connects to. Attaching the VPC to the transit gateway creates the actual connectivity between your shared services VPC and the central routing. The subnet ID parameters require at least one subnet from each availability zone where you want connectivity. Transit gateways use these subnets to place elastic network interfaces for routing. So they basically implant a network interface there. The attachment starts in pending state while AWS provisions the necessary infrastructure. Once it improved to available, traffic can flow between the VPC and transit gateway. This attachment enables the VPC to participate in the broader network topology. Other VPCs attached to the same transit gateway can reach resources in this VPC subject to route table and security groups. Resource share creation. Creating the resource share is where AWS Resource Manager really comes into play. This command creates a share that includes both the subnet, resources subnet, and the transit gateway. Those are the ARN numbers. It's basically your account ID and then the subnet ID, your account ID, and then the transit gateway ID. The principals list specifies which accounts can access this resource. You can use account IDs, organizational unit IDs, or even your entire organization ID here. Allow external principals enables sharing outside your AWS organization, but I recommend keeping sharing within your organization boundary for better security. The tags helps with resource management and cost allocation. In large environments, you'll want consistent tagging strategies for all shared resources. The invitation process ensures that resource sharing is always explicit and controlled. Target accounts must actively accept resource shares before they can use the shared resource. So the first command lists pending invitation. Your invitation. In automated environments, you might script this to automatically process invitations based on your organization policies. So this is to create the invitation, and this is to accept the invitation. The accept command creates the actual sharing relationship. Notice how the status is changes from pending to accepted. This is when the shared resources become available in the target account. After acceptance, users in the target account can see and use the shared resources through the AWS console or CLI, just as if they were native resources in their account. Direct Connect provides dedicated network connectivity between your on-prem and environment and AWS. This is typically used in enterprise environments that need consistent high bandwidth connectivity. The location parameter specifies which direct connect facility you are connecting through. Each region has multiple facility. Choose based on your geographical location and redundancy requirement. Bandwidth option specify the bandwidth from 50 meg to 100 gig. The connection starts and requested the connection starts in the requested state. AWS will provide a letter of authorization that you can take to the co-location facility. The VLAN and AWS device information in the output are crucial for configuring your network equipment. Your network team will need to know this information for them to provision the network side. The transit virtual interface is what actually carries your data over the direct connect connections. This is where we integrate with the shared transit gateway. So AWS Direct Connect, the VLAN ID it must be unique across all virtual interfaces on the connection. The ASN is your Border Gateway Protocol AS number. This is how routing advertisement happen. The MTU setting packet size to 9001 bytes supports jumbo frame for better performance. The Direct Connect gateway links your on-premises network to the transit gateway, enabling connectivity to all attached VPCs through a single connection. This architecture scales much better than individual VPN connection to each VPC. Understanding command dependencies is crucial for successful implementation. This flowchart shows how output from each command becomes input for subsequent commands. The VPC ID flows into both your subnet and transit gateway configuration. The subnet ID is needed for transit gateway attachment. The subnet ID becomes the VPC ID flows into post subnet creation, like we see here, and transit gateway attachment. The subnet IDs is needed for the VPC attachment, and both the transit gateway and subnet ID are needed. Transit gateway and subnet ID are required for resource sharing. Here we can create the resource share that requires the transit gateway and subnet ID. This dependency chain means you must execute commands in the correct order. So you typically start by VPC, then you go create your subnet, then you create your transit gateway. Now that those are created, you can create a transit gateway attachment. Now that it's attached, now you can create resources share. In resource share ARN numbers, you specify those when you do a share. Get resource invitation, accept resource invitation. So it's all building on top of each other. The resource share ARN from the sharing command is needed by target accounts. So resource share, you get the ARN and then you go to the target account and then share invitation, and then they accept the invitation, and then they connect. It becomes a connection. Each command depends on outputs from previous commands. Capture and use resource ID carefully and correctly to avoid failures. Comprehensive monitoring is essential for managing shared resources across multiple accounts. This architecture provides visibility in resource usage. Here you have the monitoring layer, the CloudWatch metrics, CloudWatch, CloudTrail logs, and both those are shared. Resource Manager, you're sharing the resources, and then this information is collected. CloudWatch metrics help you understand resource utilization across all consumer accounts. You can set up alarms for unusual usage pattern or potential security issues. CloudTrail, a complete audit trail, all resources sharing activities. This is crucial for compliance and security investigation. AWS config continuously monitors the configuration of shared resources and can automatically remediate configuration drift or policy violation. The monitoring rules layer enable proper cost allocation, capacity planning, and security governance across your multi-account. So the shared resources, consumer accounts, all those can be collected across the CloudTrail and CloudWatch logs. CloudWatch metrics, you can see the statistics, and CloudTrail logs, you can see any changes to the environment. Security is multi-account resource sharing requires careful planning and ongoing attention. The key security consideration and best practice from my experience is implementing this architecture. Least privilege is fundamental. Only share resources that truly need to be shared, and only with accounts that have a legitimate business need. Regular audits help ensure this principle is maintained over time. Service control policies at the organization level can prevent inappropriate resource sharing activities. This adds a layer of governance that's especially important in large organizations. Consistent tagging enables proper cost allocation and helps identify shared resources that might no longer be needed. Implement automated tagging policies to ensure consistency. Monitoring access patterns helps identify unusual activity that might indicate security issues or misuse of shared resources. One of the biggest benefits of AWS Resource Manager is cost optimization through resource consolidation. Let me show you the potential savings and how to maximize them. The cost savings come from eliminating dedicated resources across accounts. Instead of each account having its own NAT gateway, internet gateway, and direct connect connection, we can share these across multiple accounts. NAT gateway consolidation alone can save thousands of dollars per month in larger environments. A single NAT gateway can serve multiple accounts workloads. Direct connect sharing provides even more significant benefits and savings. A single 10 gig connection can replace multiple smaller connections, reducing both infrastructure and operation cost. The data transfer rate as well cost shows how sharing also resources would save you money. Shared cost per month here versus the cost times 3, right? So from 900 to 300 direct connect, those are saving adds up. Even with careful planning, you'll encounter issues during implementation and operation. Let me share the most common problems and their solutions based on the field experience. Resource sharing failures often stem from incorrect ARN formatting or insufficient permission. Always double check resource ARNs and ensure the sharing account has the necessary IAM permission. Invitation exception issue usually indicates problems with the recipient account's permission or organizational membership. Verify that the target account is part of your AWS organization. Connectivity problems after successful sharing often relate to route table configuration or security group rules. Remember that shared resources inherit the network properties of the owner account. DNS resolution issues are common in complex architecture. Ensure that DNS support is enabled on your transit gateway and the Route 53 resolver rules are properly configured. In the multi-environment scenario, a large enterprise had separate account development, staging, and production, but wanted to share centralized security and monitoring services. Resource Manager enabled them to maintain environment isolation while sharing critical infrastructure. The hybrid integration case involved a financial services company with strict compliance requirement. They needed consistent hybrid connectivity across multiple business units while maintaining regulatory boundaries. Shared Transit Gateway and Direct Connect provided the solution. DevOps centralization use case. A technology company wanted to provide standardized networking and security services to their development teams while allowing them to maintain autonomy over their applications. Shared VPC subnets and security groups enabled this model. The disaster recovery scenario helped the healthcare organization replicate their on-premises network topology in AWS across multiple regions while minimizing costs through resource sharing. AWS continues to expand Resource Manager capability, and it's the future is exciting for developments that will make multi-account management even more powerful. The expansion of shareable resources means more services will support cross-account. So here, initial launch in 2019, 2020, expanded the resources to add Route 53. 2021 they added app mesh, mesh builder, so they keep adding additional services as time progress. So key takeaways here: strategic value, resource access manager enables sophisticated multi-account architecture. It gives you cost benefit. It has security first because everything is controlled by the central VPC. Start simple, begin with basic use cases, and expand gradually. Plan for scale, design architectures that grow with your organization.